section 7.2 is all about converting a normal curve, which is a bell-shaped curve, to a standard normal curve, which means it standardizes it to one chart, and we can use one chart for anything that's thrown at us, okay? So today we're just going to learn how to use this chart to find areas, and then on Wednesday we'll figure out, okay, how do we take a word problem and go from there. So looking at 7.2, it just says, in this section we'll discuss how to compute the standard normal random variable and finding the area under the curve. That's going to be the key thing. There's several ways to do it. What doesn't work is some kind of simple formula. We can use a table like I have, or technology, which is a calculator software. I actually don't show you guys how to do this on your calculator. I can, but the thing is, your calculator doesn't round, and this does, and my math lab thinks you're using this. And so I was finding people are getting more angry with using their calculator than helpful, so I just use the chart, and the chart's not bad. But if you want to know how to use your calculator, I'd be more than happy to show you, okay? So how the heck do we calculate this area? We wouldn't have an infinite amount of tables if we had a table for every combination of height, weight, I don't know, whatever our random variable is. There's an infinite amount. So what we have to do is standardize it. So way back when, and I kind of mentioned it to you guys then, in chapter 3, on your first exam, you had to find z-scores. Does this kind of look familiar? Yay, nay? I said you guys will do fairly well with it on the test. You'll get it done, and then we won't have to come back to it until chapter 7. And here we are at chapter 7. So the whole idea with z-scores was to be able to compare apples to oranges. I think the example in our notes was, remember a girl was taking stats, like stats, bio, and kayaking or something, and which class did she do better on? That's the way we can say, okay, well, compared to everybody else, she did better in biology or whatever it was. So your mean's always going to be 0, and your standard deviation is always going to be 1. And that's something to kind of keep in mind, because on a normal curve, not a standard normal curve, on a normal curve, your mean is whatever the mean is for that problem, okay? So if we're talking about test averages, your mean is the 82% test average. But if we standardize it and make it a standard normal variable, it zooms down to 0. All right. So what we're going to do on Wednesday or Monday, we're going to start changing our normal variables to standard normal variables so we can use this chart. But right now, let's just make sure we can use the chart. There's going to be 3 different calculations we're going to have to calculate. Area to the left, so if we want to know like 2,100 pounds or less, or 725 or less, we're going to have to be able to calculate that. We're going to have to be able to calculate area to the right if you want to exceed 66 degrees or whatever. And then area in between if you want to be between 7 and 8 gallons. So we're going to be able to calculate all these different ways. These are in increasing difficulty. So area to the left, woohoo, that is the easiest. When you see those, get excited. Area to the right, there's a little something we got to do. And area in between is a little bit harder, okay? So first, let's see if we have to figure out the area to the left using the table. So say we want to find the area to the left of z equaling 1.68. The first thing I want you to realize is that they are giving you the z-score, okay? You have not had to calculate it. So starting 7.2, they're going to give you z-scores, but eventually halfway through, you're going to have to calculate them. So looking at this chart, it's beautiful, all right? We have a lot going on. Please notice that 0 is like right here in the middle, okay? This left-hand column is the 1s and 10 spots of your z-score, and then these up here are the hundredths place. So 1.68 has to be split up as 1.6, so you would go down to 1.6, and then you scroll to the right to 0.08. Do you guys see that? So that's what I'm just kind of telling you here. To break up 1.68, you have to go down to 1.6 and over to 0.08, so we can figure out what the probability is, okay? So this is yours to keep. Guys, you're going to use this chart for the rest of the semester, so write all over it, whatever you want to write, the little notes, okay? So these are your z-scores. So if you go down to 1.6 and you scroll over to 0.08, what do you guys find? 95/35? Is that what you get? So the probability would be 95/35 or 95.35%. So to kind of just give you a picture, what the heck did we just find? The mean is 0, and we labeled 1.68, and we're shading the area to the left. And again, have fun with this, you little artsy people. I'm not very good at it, okay? So what did we shade? We shaded a majority of the graph. What is the total area of the graph? 1 or 100%? So when we go to look up the area, if we've done it correctly, it should be a pretty big number. In this case, it is 95%. Okay? And right now, this means nothing to us. It doesn't. We don't know what z-scores are. But eventually, these z-scores are going to represent everyday, real-life values. Okay? So like I said, even if you don't like math, but maybe you're artsy, have fun with the shading and all that stuff. All right? To the left of is what your table gives you. So again, I don't know if you want to label that somewhere. So these, how am I going to write that? On this side, maybe write areas to the left of, or whatever you want to write. All these are areas to the left of, all right? Notice they show you that right up here. They're trying to show you. You found areas to the left. What else we might want to write on here is maybe the z-score formula. Z equals x minus mu over sigma. So we'll remember that eventually, okay? That way maybe you don't have to flip to your notes all the time when you want to standardize. And then the last thing I want to tell you, and then you might add more to it, is area, remember, represents three things: probability, percent, proportion. So when we're finding all the areas in here, we're finding probabilities, percents, or proportions. So we found 95% of the graph, or a probability of 95%, or whatever it may be. And again, you guys are more than welcome to label any other notes that you have. So area equals probability, percent, proportion. And these are all the areas to the left. So go ahead and flip to the top of page 6, guys. The areas to the right are a little bit tricky, but you guys stayed on page 6. I'm going to go back to page 5. Let's see if I can make this make sense to you. What do we know about this entire curve? If I shade it, it equals what? 100%. So if 95% lies to the left, what percent lies to the right? 5%, or 4 point right. Oh, you're even more exact. 4.65, right? So that's what we're doing, okay? If we have areas to the left, we actually are given areas to the right. It's just the complements, right? Because someone's like, well, why don't we just have a chart for it? I'm like, you don't need a chart for it, right? So anytime you're asked to find the area to the right, do look it up, okay, and say it's going to be 1 minus that. So Spencer over there was already doing that for us, okay? So what we're going to do is we're still going to look up 1.68, right? So let's look, I'm going to draw this so you can kind of get a picture again. So we have 0 and we have 1.68, and when we look up 1.68, we get an area of 9535, right? But we want this area. Right? When you look up any given z-score, they're going to give you the area to the left, but we want the area to the right. So what do I just have to do? 1 minus. You got it. So 1 minus 0.9535, is that the 4060 or 465 that we were talking about? Or 4.65%. Does that make sense to you guys? That's something, for some reason, be careful if you forget your z-chart, because this is called your z-chart. Because there's different z-charts. Where I was taught where they actually had it start halfway, so it was 50. I don't know. Mine had like a 50% thing, and it was really hard to remember what I needed to do. So our chart's going to tell us area to the left, but really it's told us area to the right as well. Hopefully that makes sense to everyone, but there is a shortcut, and I always hesitate to tell you a shortcut, but there's about half of you, like 50-50 of you guys kind of keep this in mind. What is something we know about our chart? It's symmetric, okay? So if we know the area to the right is here, that's the same thing as the area to the left of what number? Negative 1.68. Look up negative 1.68 on your chart. Negative 1.68. What do you get? The 465. So anytime you need to find area to the right, you can look up the opposite of your z-score because the tails will be equivalent. I tend not to use that way. I'm like Mrs. Oh, I know it's 100%, so I'm going to subtract it from 1, you know. So if it's 100%, I know it's this, I'm going to subtract it from 1. But all these tails are symmetric. So whatever's to the right of this is equivalent to the left of this, and we know left z-scores. So you can always just look up the left of the opposite, okay? So about half of you will use that symmetry rule. About half of you will, I call this the complement rule. All right, last one, we need to look up areas in between z-scores. So let's go ahead and get a drawing. We want to find area in between these two z-scores. So let's draw it first. I should have given you more room to draw. So we have 0. Where would negative 0.51 go? Somewhere over here. I'm not picky on like where you put it, but since it's not quite 1, you know, it's not going to be horribly far away. And then 1.87 is almost 2, so he's going to be a lot further. The main thing I look at is that you draw the negatives to the left of 0, right? And the positives to the right of 0. And then what do we want to shade? The area in between. Okay. So I'm going to kind of flat out tell you how to do it, and then I'll explain to you why the rule is what we do, okay? So what it says is we're going to look up the area to the left of 187. So let's look up 1.87. So z equaling 1.87, what's its area? 9693, okay? And then look up the other guy, the negative 0.51. What do you get when you do that? 3050. And then we're just going to subtract the 2, and that's going to be our answer, okay? And I'll tell you why this works. So we're going to take 9693, and we're going to subtract 3050. So we get 6643 or 66.43%, and that's going to be our answer. So that's the percent of the graph that we shaded, that's the proportion that we shaded, and so forth. Let me tell you why it works, because some people think it's just magic. But when we looked up 1.87, we looked up all this area. Did we want all this area, though? No. What do we want to get rid of? His area. So all we're doing is taking the large area, aka 9693, and subtracting the area that we don't want, 3050, and it leaves us with this area that we do want, okay? Even if it doesn't make sense, just remember, always look up your furthest guy first, so the bigger area first, minus the smaller. And if you forget which order you do it, what would happen if we had flip-flopped these? What kind of area would you have gotten? Negative. Can area be negative? No. And what does area represent? Probability. Can probability be negative? No. So that's just your hint, like, okay, I got to rearrange them. Okay? So if you want area to the left, celebrate the small things in life, woohoo, you just look it up right here on this chart. If you want the area to the right, you have to use the complement rule or the symmetry rule. And then if you want the area in between, just look up the furthest right and subtract the left. Okay? So